guys, we're going to do some of these graph questions here, okay? So we have questions, I'll go for question 2 and question 5 first, okay? Okay guys, so what first thing we're going to do is going to try and get out the calculator and we're going to input the... Okay, so here's what we're going to do, guys. We're going to enter this into the calculator f of x, okay? And in the domain, so we're going to get 3 bracket 2 to the power of x. Okay, so 3 to the power of 2x, okay? And you'll see these are exponential graphs, so they're going to have a curve, okay? I think we're all very familiar with exponential graphs given our current situation in the world. It's going to be a rapid increase, okay? So here we go. So this question is basically, it gives us a load of decimal points here. Now you see the decimals are going to be quite hard to draw. Okay, so it's going to be quite a difficult question to draw. Alright, so we're going to have to get all these points listed out, and then we're going to try and attempt them on graph paper, right? So here's the following, here are the points we had to do there. So what did I do? I did 6 and did 3 by 2 to the power of x. So I did the question 2 there, okay? So f of x equals 3 by 2 to the power of x. Sorry guys, just doing on my own one at the moment. 3 to the power of x. Yeah, and then minus 4 to 2. Okay, let's see what points we have here. Okay, so we had minus 4 and 0.1875. Yeah, good luck to me figuring out what that is. Minus 3 and 0.375. Okay, minus 2 and 0.75. Minus 1 and 1.5. 0 and 3. 1 and 6. Finally 2 and 12. Now, I suppose the best way of doing this is I might try and extend this. Let's see how many blocks I have down here. So we're going to put a line. So there's 4 to the left and 2 to the right. So we're going to draw a line around here, okay? Because we need more to the left than we do to the right. Okay, so there's our line. Then we're going to draw a horizontal line. We have to go as high as 12, but as low. So we have a high and a low there. So this one's our low. This one's our high. So they're all above the x-axis, which is good. So there's no negative values, which we can deal with nicely. Okay. Now, the way to maybe make this a bit easier for us is that we have to go as high as 12. So let's count how many blocks we have. We have 3, 6, 9, 12, 15, 18, 21, 24, right? So 24 blocks there. So I reckon we can make every 2 blocks worth 1. So let me explain what I mean. 2 blocks are worth 1, 2 blocks are worth 2, worth 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so see that? Okay, now I'm going to stand out the other ones. I'm going to make every 3 blocks worth 1 here, just to make this a bit easier to draw. Minus 2, minus 3, that's going to be minus 4, this is going to be 1, and then 1, 2, only as far as 2 on this one, right? So let's start off with the points we find easy. 212. Well, 212 is up on this line here, so there's 212 there. Make your dot reasonably so. We got 1, 6, which is this one here. We got 0, 3, which is this one here. Now it's minus 1, 1.5. 1.5, we're able to do quite well there. Minus 2.75. So if you look at here, that's a half. So 0.75 would be halfway in between them. Then we have minus 3, which is 3.75, which would be below halfway. And then finally the last one is quite low around here. As we can see, this exponential growth, which is quadrupling in, which is doubling in size every time. Okay, so the thing to know, oh god, it's a curve like so. Now in the formula, we can see that it's a 3 by 2 to the power of x. See the 2 to the power of x part here? Okay, the 2 to the power of x part means that it's going to be doubling every time. So we can see here is that if you look at your y values, what we can see here is this 0.1875 doubles into 0.375, 0.375 doubles into 0.75, 0.75 doubles into 1.5, 1.5 doubles into 3, 3 doubles into 6, and 6 doubles into 12. And that's how this type of graph works. Okay, so guys, that's our first graph done, which is question 3. So I'll just keep this here for time being and see what we have to do with the next one. The next one is 6 by 1/3 to the power of x. So we get 6 in here. Then we get 1/3 to the power of x down here, like so. We have to start at -1 and end at 3. So we start at -1, we end at 3, step of 1, and you can see here are my points. Okay, so 6 by 1/3 to the power of x. Okay. Now, we're going to make a list of all these points and attempt to graph them. Okay, so here's what we're going to do. So, rub all these points out. Let's start afresh and see if we can get this graph up and working for ourselves. So -1 is 18. So this graph now doesn't work because we don't go as high as 18, so we're going to have to fix that right away. 0, 6. We're going to go, sorry, -1, 18, 0, 6, 1, 2. It's this one here. And then we have 2 and 0.666, which is roughly 2/3. And then we have 3 and 0.222. So reoccurring means it goes on forever. So what we're going to do with this graph here is we're just going to rub out the numbers I previously had in it. And this time every gap of 2 is worth 2. So 2, 4, 6, 8, 10, 12, 14, 16, and there's 18. There's our max point there. Now we have to go as high as 3, so I need a 3 here. So let's do our points. -1, 18 is here. 0, 6 is here. 1, 2 is here. 2.6, so 1 is here, and then 2/3 of that will be around there. And then finally the last one is quite small, 0.2, so in around there. So we do our best is to link this line up like so. We try and get through as best we can, and there we go. Okay, that's a reasonably good attempt at an exponential curve. Okay, so once again, I'm just going to get rid of all this these workings I have here. And what we'll do next is move on to the next question. So we've done questions 2 and 5. Now I'm on to 7. I'm on to question 7, okay? So in question 7, I have to draw the graphs out twice, all right? So the first graph I'm going to do is 1/2 to the power of x, like so. And I have to do it from -3 to 2. I have to draw both graphs on at the same time. So here's my numbers here: -3, 8, -2, 4, -1, 2. Okay. So gotta get that done. And it's from -3 to 2. Okay, let's write in our points here, okay guys, because these are all our points: 0, 1, 1 and 1/2, Then you have 2 and 0.25. Okay, so let's get that down here and see what we can do. So we got minus 3, 8. We got minus 2, 4. We got minus 1, 2. We got 0, 1. We get 1.5. We get 2 and 0.25. Okay. Let's begin. Minus 3, 8. So yeah, I can use the old one where I have a gap of 2. This will help me nicely. So minus 3 goes up to 8. So where's 8? Minus 3. 8 is this one here. Minus 2 to 4 is the next one. Minus 1 to 2. 0 to 1. 1 and 0.5. And 2 and 0.25. Okay. We link it in like so. And there you go. There is your exponential graph of the first one. Now we got to do the second one, which is 3 to the power of x. So 3 to the power of x, you'd be expecting it to increase by a factor of 3 each time. See the way this is a half x. So see the way this is f of x equals to half x. This means it's going to be getting halved every time. So if you look at your last question, if you look at your last points here, see the way they're all getting halved. 8, 4, 1, 2, 1, a half, a quarter. It keeps getting halved every time. So the height, if you were to look at this in terms of like a bar chart, 8's the biggest one. The next one is half the size of the 8. The one after that is half the size of the previous one. Half the size of the one becomes before that. Half the size of the one becomes before that. You get the gist, okay? So there's a pattern there that you're getting halved every time. Now the next one is 3 to the power of x. And with 3 to the power of x, what you're expecting is it's going to keep getting multiplied by 3 every time. So it's going to be tripling in size every time. Okay, so we can see minus 3 and this number here, minus 2 and 0.111. Now we can see that's tripling. See that 0.111 then turns into 0.333. That should turn into 1, turns into 3, turns into 9, and that's it. So we're lucky that all those numbers fit into our graph. Okay, so let's start off with the first question. So the first one is going to be minus 3.037 minus 2.111 reoccurring, so put the dot above it, minus 1.333 reoccurring, put the dot above it, and then we got 0 and 1, 1 and 3, and 2 and 9. Okay, so we're going to draw this out using the purple one here. So minus 3 starts off at a very small number, so it's very close to 0. And then minus 2 starts off at 0.1, and 0.1 is going to be once again very close to 0. And then we got minus 1 and a third, so a third is below at the halfway line here. See, that'd be 0.5 where my pen is at the moment, so I need to just bring it just below 0.5. And then we got 0, 1, which would be this point here. You can see that seems to be the intersection point between the two graphs. Then we got 1, 3, which is this one here, and we see it's quite a steep rise. And then we get 2, 9. Okay, you see that there. There we go. Up we go. So there you go. There's your two graphs there. Okay, so that's 3, 5, and that was question 7. So I suppose I should do 8 and 9 as well. Really hit it home. So we have question 8, and then we're going to have a question. We have to do question 8. We have to draw both graphs on the same page. So I suppose the first thing we need to do is need to get all the points. Okay, so once again, I'm just going to go to your calculator, enter in 3 to the power of a half x. So put the half there. and put the 3 in front. And then starts at -1, ends at 3. Step of 1. Okay. So this is 3 to the power of a half x. So because it's to the power of a half x, see the half x here? Means it's going to be halving every time. So the previous number will be getting halved every time. So if that doesn't happen, you know something's up. Okay, so what's it? -1, 3, step of 1. Okay, let's find out what we're up to here. Okay, so we got -1 and 6. We got 0 and 3. We got 1 and 1.5. We got 0 and 3. Sorry guys, I think I read this wrong. 0, 3, 1, 1.5, 2.75. Oh, sorry, that's a 2. 2, 1.75, and 3 and 0.375. Those last 2 points are awful. 2 and 0.75 and 3 and 0.375. Okay, before I draw this out, I should probably check out the other one as well, the 4 minus 2x. Okay, so once again, just go to your calculator, enter in 4 minus 2x. Should be a straight line with a slope of 2, which means that it loses 2 every time. The output value will lose 2 every time. Starts at -1, ends at 3. So you can see that the first output value is 6, then it goes to 2, 4, 2, 0, -2. Okay, so this caused the -2x here. In lines, this tells you how much it loses. Okay, so we're going to write down all the points of this graph now. Okay, so we'll write it over here. We got -1, 6, which seems to be an interception point. We got 0, 4. We got 1, 2. We got 3 minus 2. Oh, sorry, 1, 2, 2, 0, and 3 minus 2. If you look at the question, from your graph, estimate the points. It's plural, so it could be 2 points of intersection, okay, of f and g. So you have to, it's your first graph versus your second graph, okay? So I'm just going to grab my graph paper here. We're going to get drawn this and then see what happens, okay? So here's my graph paper. We got the purple one, which is f of x, and the red one, which is g of x. So your g of x, you are f of x. Okay, and what we're going to do next is we're going to draw this out. So -1, so we do this. It has to only go as high as 6, so we can actually stretch this out quite a bit because we're only going as high as 6. So maybe we could even make 3 blocks worth. 3 blocks could be worth 1 in this question. Okay, so see, we can make this maybe easier. So that's 1, 2, 3, 4, 5, 6. Arguably, I think we might be even able to get away with 4 blocks worth 1 here. Try and make this as large as possible. The larger you can make it, the easier it is to write in the numbers. 1, 2, 3, 4, 5, 6. See the way I've really stretched that out? Okay, then I can just do 3 blocks for the bottom one. So that's 1, 2, 3. Okay, so I'm going to start off with the red line. The red line's quite easy because it's -1 and 6, which will be here. Then 0, 4. Then it's what's it? 1, 2, then 2, 0. Nope. Now, only problem I made here was that I can't fit in 3 minus 2 at the moment. So that was technically an error on what I was doing here with the graph. So I'm going to have to pull it down slightly and see if we can fit in 3 minus 2 somehow. So I've got to drag this graph. Lucky for me, my mistakes don't get punished as much because of obviously I'd have movable graph paper, but in an exam I'd have to redo this, which is not great. So that's -1. Then if I bring it down a bit lower, that's -2 there. So that last point I didn't take it into consideration, so that would be me having to redo this from scratch. So there's the last red spot there. What you can see is that we can make ourselves a red line here with all the red spots. I finish it off. Oh dear, might finish it off in a second. See if I can. There's 4 of the points anyway. And hopefully I should be able to pick it up and extend it to the 6th point. There we go, I can indeed. So that should have been like that. So that was my bad. Now, the purple, which is up here, we got -1, 6, so we actually have the same common point, which is this common point here. Then we have 0, 3. I'll probably use green now that I think about it. 0, 3, which is here. Then I have 1 and 1.5. 1 and 1.5 will be 1.5 will be 2 blocks up because it's 4 blocks in total. So 1, 1.5 will be here. Then we get what's it, 2 and 0.75. So 0.75 would be 3 blocks out of 4. And then finally 3 and just below the half. Yeah, this part's annoying me, that's where it should be. And 3 and what's it, 0.375, so 0.375 is there, okay? Now look at this. Whoop. Here's your numbers like so. There's the rest of the green graph. Then I have to link this one to here, and there's my exponential graph there. Now where are the 2 points at which they hit? Well, 2 points I see are -1, 6. I have to figure out what this point is here. It's an awkward one for me, so just have to estimate it, don't I? Estimate the points of intersection, so I'm going to do the best estimate I can. So we know -1, 6 is 1 point of intersection. I'd say about 1.5 and 1 maybe. 1.5 and 1 might be the 2nd point of intersection. You only have to get a rough estimate of it anyway, so it's no big deal. Okay, moving on to yet another question. Is question 8 or 9, I believe. Question 9. So for question 9, once again we're going to be drawing out these graphs from -2 up to 1, and we'll see what happens here. Right, so we got the f of x graph, which is here, which is going to be 5 to the power of x, 5 to the power shift x. Start at -2, end at 1, step of 1. There you go, you get -2.04. You get -1 and -1 and 0.2, so they're all increasing by 5. That'll be 0, 1, and 1, 5. Okay, so there are all the f of x values. Now, as for the g of x values, which I'll be helping to put here, okay, we'll enter this into the calculator as well. So g of x is 2 plus x. So 2 plus hashtag x, or alpha x I mean, minus x squared. Okay. And then you start at minus 2. You end at 1. And you have a step of 1. Okay, so we have the following points: minus 2, 4, 1, 0, 0, 2, and 1, 2. Okay, now as I always say with these ones is it's a n-shaped curve because of the minus x squared, but you have 2 points at exactly the same height. So I'm going to show you there's a bit of a trick with this one, which you'll need to be aware of. See the 0, 2, and then you can also see the 1, 2. Now see the way they're both at the same height. I'd be inclined to look at the 0.5 here, okay? So what I'm going to do is I'm going to change the step to 0.5. And then I can see what value 0.5 would be. 0.5 is 2.25, okay? So I'm going to try and put this point in as well, just to make things a bit easier. Now, this question doesn't have the biggest range. What does it have? It has a range of minus 4 going as far as 5. So I'm going to need, say, gulping 2s with 18 blocks, let's say. Let's find out. I really stretched the x-axis this time though, I'd say. So let's begin 1, 2, 3, 4, and 5. Minus 1, minus 2, minus 3, minus 4. Right, there's that part done. Going to stretch the x-axis a bit. 4 blocks to go, so that'll be 1, and that'll be 2, and then that would be minus 1, and this one will be minus 2. Okay, should be able to do these points quite easily. I'll start off with the f of x, the black ones first. So minus 2 on 0.04 is very small, like literally on the axis. Then we have minus 1 and 0.2. Well, this is 0.5, so 0.2 will just be a bit above the axis there. Then we have 0, 1, which is here. And then we just have 1, 5, which is here. So you can see it's quite a steep increase once it gets towards the 5 like that. So that is our curve there. Next one is the n-shaped curve. So it's minus 2, minus 4, which is down here. Then it's minus 1, 0, which is here. Then it's 0, 2, which is here. Then it's 1, 2, which is here. But then we also forget about the half, which is at 2.25, which is around here. Okay, now we're going to try and draw up this graph, okay, see where it intercepts. Goes here like so. Then we're getting our n-shaped curve. There we go. So roughly 2 points. I'll try and do them in blue once again. You don't have to be, you can only be as accurate as you can be, to be honest. So I would say about 0.4 and 2.3 for this point here. 0.4 on the, it's below 0.5 on the x-axis. Sorry, my fault. I shouldn't have done it that way. I'll do lines, dotted lines. So straight down. I suppose 0.5. 0.5 and 2.4 for that one. And it's the first intersection point. And then the second intersection point will be, I don't know, 0.8 and just below halfway, minus 0.8 and 0.4 for the blue dot there, the second blue dot. Okay, all right, guys, that's us. So we did questions, we did 7, 8, and 9, and we did 2, 5, 7, 8, and 9, and that took me 29.